In this next section in probability, we're going to look at independent events. Independent events are events that do not affect each other. For example, if I roll dice 1, the outcome will not affect the outcome when I roll dice 2. And if I rolled a dice, the outcome of rolling the dice would not affect the outcome when I spin the spinner. This is because the two events are not linked, or you could say they are independent events. Now, we've already done some questions like this using space diagrams, but in the next couple of questions we're going to find the answers using multiplication. So here's our first question. What is the probability of getting a 6 on both dice? Well, we could just draw up a space diagram like we did before, and we would see here that we could get a 6 and a 6 just one way, and that there are 36 possible outcomes, which would give us our 1 in 36 chance of getting a 6 and a 6. But drawing a space diagram can be time consuming sometimes. So let's work it out by multiplication. Using multiplication, we use the formula probability of event A multiplied by probability of event B, or PA times PB, where event A is dice 1 in this case, and dice 2 is event B. So let's start off with our formula again. PA times PB. Well, the probability of getting a 6 on the first dice is 1 out of 6. And the probability of getting a 6 on the second dice, or event B, is also 1 out of 6. So we just multiply here. Top times top gives us 1. And bottom times bottom gives us 36. So the probability of getting a 6 on both dice is 1 in 36. This next question asks, if the spinner is spun twice, what is the probability of getting A, 2 greens, B, a blue and a red in any order, and C, a colour that is the same on both spins? So A, first of all, the probability of getting 2 greens. And we'll start off with our formula. So it's the probability of A multiplied by the probability of event B. And the probability of getting a green is 1 out of 8. There are 8 different colours. There's only one green, so you have a 1 in 8 chance of getting a green. And the second time you spin it, you've also got a 1 in 8 chance. So top times top gives us 1, and bottom times bottom gives us 64. The chances of getting a green on both spins is a 1 in 64 chance. And now we look at B. The probability of getting a blue and a red in any order. So we'll have to consider 2 ways of doing this. We could get a blue and a red, or we could get a red and then a blue. Let's do the first one first. So the probability of getting a blue multiplied by the probability of getting a red. Well, the probability of getting a blue, there's only one blue, so it's a 1 in 8 chance. And we're going to multiply this by the probability of getting a red, which is also 1 in 8. And that's going to give us a probability top times top and bottom times bottom of 1 in 64. But remember, we could also get a red, and then we could get our blue on the second spinner. So that's going to be a 1/8 multiplied by a 1/8, which is also going to give us a 1 in 64 chance. So there's 2 ways we could get the blue and the red. So we need to add these 2 together, and that gives us a 2 in 64 chance. And we can simplify by dividing by 2. 2 into 2 goes once, and 2 into 64 goes 32 times. So there's a 1 in 32 chance of getting a blue and a red in any order. In question C, a colour that is the same on both spins. Well, the probability of getting an orange and then an orange is 1 in 8 multiplied by 1 in 8 is 1 in 64 chance. In fact, there's a 1 in 64 chance of getting any of these colours on both spins. So all in all, there are 8 opportunities, each with a 1 in 64 chance that a colour is the same on both spins. So we need to add here. So 1 in 64th plus 1 64th plus 1 64th and so on gives us 8 over 64. And again, we don't leave it like that. We try and simplify. 8 into 8 goes once, and 8 into 64 goes 8 times. So there's a 1 in 8 chance that a colour is the same on both spins. And finally, if the dice is thrown twice, what is the probability of getting an even number both times? We'll start off again with our formula. So the probability of A multiplied by the probability of B. Well, the probability of getting an even number when we throw the dice the first time, there's 6 numbers in the dice, so the even numbers are 2, 4 and 6. So 3 out of 6 are even. And we can simplify that down to a half. And the second time that we throw the dice, obviously the probability is still going to be a half that it lands on an even number. And half times half, remember it's top times top, and bottom times bottom, is a 1 in 4 chance. So there's a 1 in 4 chance that you'll get an even number both times if the dice is thrown twice.